Hello everyone, my name is Athulya. I am a grad student here at UMass Amherst, and this is my project Agentic GraphRAG. So, multi-hop question answering has been a very well-known problem in this field. Most AI retrieval systems are built for simple one-question answering. For example, when was Apple founded? So you just retrieve the document which has this answer and you're done. But in real world, questions are rarely that simple. For example, at the arena where Lewiston played, how many people does it seat? So step one for this would be finding which arena Lewiston played in, and then step two would be finding its seating capacity. So two documents, two hops, but one question. This is called a multi-hop question, and then to answer this multi-hop question, the standard retrieval fails because the standard retrieval sees one chunk at a time and doesn't have the context of the whole corpus itself. So that's where knowledge graphs come into play, and we'll look into how the system solves that question. So let's look into what a traditional RAG is. A traditional RAG splits documents into sentences, converts it into vectors, stores the vectors, and then finds semantically similar vectors to your query so it can answer to your particular question. So you just have to find the right document, and then you have your answer. It's great at finding facts, it's fast, but then it's conceptually blind. So that's where GraphRAG comes into place. How a GraphRAG works is basically it has entities and relations, and the graph is stored in like a knowledge graph DB, like for example Neo4j. So the way it will be stored is, for example, let's say Apple, which is a company, is an entity, and we have Steve Jobs, who is a founder, and then the relationship will be very clear and very visual in this graph. So the strength is that it treats the knowledge as a connected network, and it's great for multi-hop reasoning. The limitation is that it can easily go wrong and it's quite fragile, because if any entity in this whole multi-hop is missing, then the connection fails and it just goes cold from there. So it is context aware. It can answer for the whole entire corpus, but then it has its cons. But it's still a good sign, right? But then still, why isn't everyone using it? So the number one issue is that it's quite expensive to build. In a vector DB, you just dump text, dump the embeddings, and save it, and it's cheap and fast. But then in a graph, you must extract the correct entities, the correct relationships, and so because of that, the ingestion is very slow and it's very labor intensive, and often it requires people who have a lot of domain expertise to identify and make the graph, and that is very time intensive as well. So our system addresses this by building a knowledge graph agentically, by inferring the schema directly from the documents. And when it comes to latency, vector search is very fast. It's in milliseconds, but then graph can take time because it has to again traverse across multiple paths. So a graph rag is really, it can come in handy, especially in fields where you need the exact information. You need very accurate information. For example, healthcare, finance, legal, and it's good with global summarization, and it can answer multi-hop questions. But at the same time, it needs to be very properly constructed, because if you miss any one entity, it the retrieval fails. So since just building the knowledge graph itself is very labor intensive, I was wondering if we can automate it somehow. So that's when I came up with the system, the Agentic GraphRAG. And with this, with the help of multiple agents, I am able to build a knowledge graph which is of a decent quality. We can't still compare it to the ideal graph, which is hand built by people, but it's still decent and it provides good results. And once you've constructed an knowledge graph via agents, then later maybe a specialized person can come in and fix the things. But for this experiment purpose, I haven't done that. I built it only using agents and to experiment and see the results. So in this particular pipeline, I have 7 different agents. First agent is a schema inference agent, which infers the schema from the documents and identifies the entities and relationship types. Then comes the entity extraction agent and the relation extraction agent and the schema alignment agent. Initially, I had a setup where I didn't have so many different agents. I just had 2 or 3, just the entity extraction and the relation extraction agent and the schema agent. But the quality of the knowledge graph that was built was not very great, and the performance wasn't that good. That's when I introduced a 7-step system, and the performance have significantly improved. We also have a conflict resolution agent. For example, let's say there's a fact that a particular company was founded in a year, and there's another fact saying contradicting that the year in which it was built. So the conflict resolution agent debates between these 2 facts and comes to a conclusion on which one's the right thing, and then saves that information. We also have a confidence evaluation agent. So only things with a higher confidence get stored. So this way, a knowledge graph was constructed autonomously using agents. Parallelly, I've also used sentence transformer and created a vector DB and stored all the document text as embeddings in it to compare the results. So this is what the knowledge graph looks like. And we can query this by using a simple Cypher query. Cypher query is very similar to SQL, and it's easy to learn, and it's very, like, you can interpret it just by looking at it. So if you look closely, Doctor Strange is one entity, and it is connected to different things like the year, Walt Disney, Marvel Studios, Marvel Comics, etc. So now we have our system. We have our vector DB, things stored in our vector DB, and our graph, which is autonomously built. So I wanted to test different retrieval methods to find out which is the best retrieval. So we have a vector retrieval, a graph retrieval, which is graph traversal, and the vector retrieval uses a dense retriever, and a hybrid, which is a fusion of both of these. And then I've also have an orchestrator. Right now, the orchestrator just routes queries based on very specific, simple rules. But in the future, we can, after we have a lot of data, we can train it to route particular queries to those retrieval, which will give us the best results after learning from the results. And I also have a few agents to track the performance. And this was the initial test setup. Took a small corpus of 25 documents, and 25 queries and its related documents. And these are the basic stats for the nodes and relationships of the graph, and then the vector embedding size. And the results are in. Hybrid has outperformed both the vector and graph. So these results are interesting because I expected graph to do better, but graph actually fails more often than we think because the entities are not perfect. Like I mentioned earlier, if the very first entity is missing, like it can't really hop on anything, so it just goes cold. Or sometimes when we are hopping multiple times, if there's one entity in the middle that's missing, it goes cold again. And vector is just a straight dense retrieval, semantic similarity based retrieval, and the hybrid is actually the best of both worlds. So how hybrid works is that vector runs first. It searches for semantically similar sentences and gets the correct entity. And once the entity is at hand, the graph expands upon it. And once we have that, we combine it, deduplicate it. So basically, graph and vector both has its strengths, and hybrid is a good combination, and it covers both. It catches things with which vector misses, and it catches things which graph also misses. So that is a conclusion. The hybrid is actually doing pretty well with an exact match score of 68%, outperforming both the vector and the graph only retrieval. And the other key finding is that the agentic graph RAG, which was built, the results are very similar to the ideal knowledge graph which is built. So I think the results are like pretty comparable. And the ceiling for this, another thing which I've noted was that the ceiling is we have an LLM answering layer that particularly sometimes, even if you give it the right answer, right document, if you fetch the right document with a retrieval and give it to it, it still sometimes gives us the wrong answer. It's because of various reasons like LLMs hallucinating and things like that. So that's a ceiling, but overall this, we found that hybrid retrieval is a very good method to go ahead with, and it outperforms both. And that concludes my presentation.